Okay, thanks for letting me know. Okay, then I guess then we have to do this session again because I have completely worked on the session and multiple shows all the those parameters. I guess that was earlier Shashwat and Pulkit Rajput was trying to tell me. Yeah, but I have performed so much of demo. So basically should I start a new session now or like what should I do? Or I should go ahead with this and just explain it what I have done in this video because I guess I have spent most of the time right now without it. So what's your suggestion, Sairam? Please let me know. Okay, I was talking since I guess half an hour and I have done such a demo, but now what should I? Should I go for another video or I should continue and just explain what I did in this video and then go into the next one. Okay, Sairam, definitely I can go ahead from starting and explain you everything what I did in this video. So, like what I have done in this video, first I have set up this. So in the last video, we have done till here. We have created the estimator. So in this video, I have set up the hyperparameters. So there are different hyperparameters which I have set up here. So I explained about each of them. First, we have talked about this max depth. So basically, max depth represent the maximum depth of the tree which we want to go with, and if you increase this value, this makes the model more complex and it is likely going to be overfit. It is going to be an integer value and it ranges from 0 to infinity and its default value is 6. So basically if you don't want your over so your model to be overfit basically means uh, like uh, if you overfit is basically mean when you are using the training data and your model becomes so specific to your training data that whenever you provide that data which are used for training, it will give you a perfect result. But when you provide a new data, because in generally what we want to do with the AI and machine learning, that it can predict something using new data, it can generate something with the new data as well. Okay, whatever the new question, it not only whatever we have provided as an input to the our model, it not only going to provide that, it comes up with a new data as well. Okay, but if you if this max depth is going to be has high value, then your model will perfectly work with this training data. But when you provide the new data to it, it is not going to give you a very good result. Okay, it become very specific to that training data. So we are going to keep this max depth value as low as not as low as possible, slightly we generally keep it between 0 to 5. Okay, and the next hyperparameter which we set up is ETA, which represent the learning rate or the shrinkage parameter. It basically control it shrinks the feature weights to make the boosting process more conservative, and the lower value of this makes the optimization process more robust, but it becomes slower as the value goes from as the values goes down. Okay, so after each boosting step you can directly get the weight of these new features. So its value ranges from 0 to 1, and it is a float type of data. So like its default value is 0.3, but as you can see here, we have put our value as 0.2, slightly lower than, because all these are regularization term. Basically we are controlling our data using that. And hyperparameter, as I already told, but I can told it again, like in the previous video I already told that these are the like configuration setting. Basically just like we use different files in our more modeling into our simple coding as well, like we set up some configuration setting which are not basically learned from the training data, but we have to set up during the so that we can influence the behavior of our learning model and influence how model is going to be learned and generalized from the training data. Okay. And then we have this we have this again gamma. So it is the minimum, it represents the minimum loss reduction required to make the further partition of that leaf node of the tree. And it encourages pruning of that tree, so we don't want to go it like deep and containing creates multiple layers into train itself. It is going to be waste of my resources. Okay. So a large gamma value leads to a more conservative algorithm, means it will work fine with the that particular training data, but with new data it is like going to be like difficult to work with that. Okay. And it also float integer type, and defaults value is 0. So I have put it as gamma as a 4 here. And then again is the next parameter is the subsample, which basically control the fraction of the samples. So samples in machine learning here means instances, like EC2 instances, or basically computers in simple terms, which are used for training each tree. And if you like it ranges from 0 to 1, and if you set it to 0.5, it basically means that XGBoost randomly collect half of the data instances to grow tree. And this basically help us prevent overfitting. And any value if you put it less than 0, it basically introduce randomness into that data and help us prevent overfitting. Next is the objective we put, which is the learning task and the corresponding objective function, and we set it up to as a binary logistic. So this binary logistic indicates a binary classification problem with the logistic regression, and we have to provide it as a string. So because here I want my model to be predicted what is income is going to be greater than 50,000 or not. So that is basically a binary problem. It is going to be or it is not going to be. So that is a binary logistic issue. Okay, and the last hyperparameter is num round. It basically represent the number of rounds I want to go, like how many times I want to it can train my model and increase its efficiency, increase its performance. Basically number of boosting iteration it represent to build that model, and it is always to be an integer type. So here I represent I allowed it to go up to 1,000 times. So if you like in the last I have configured it, we have to configure the data flow here. So after setting up all these parameters, I have to like set up the input for my training model. So here I have set up the path of it, because I already uploaded my data set into CSV format into Amazon S3. uh, Here first I converted them into CSV format, and here I uploaded my training dataset as well as validation dataset to Amazon S3. Okay. And then here I'm providing that as an input and storing them into a variable train input as well as validation input. And then I use this fit method to actually start my model training. So fit method is utilized to fit is basically we are uh, adjusting our model according to what our training data set. So I provided training input and the validation input here, and I then included this weight equal to true, which basically which basically tells this fit method to display the progress log and wait until the full training is complete. It should not like always starting displaying me the result. and it should continuously show me. So that's why you can see it showing me every progress every second, that what is going on in that part. So it first started the training job and create this report, XGBoost report, and then another report is profiler report. Okay, and the it like trains those instance, prepare the instance which we provided when creating this estimator, the MLMX for large. And I also you can see that into this section. If you go to this training section into your SageMaker, and if you just search here for SageMaker, then you will come up to this page, this one. And here in the training section, you can go to this training job, and here you found this your job here, and you can see it is completed. So basically what happened here, it prepares the instance for it, then it download the training image which is there in the elastic container registry, where we also have the Docker images and all type of images we have, which is the service from the AWS. Then after the download is completed, training is started in progress, and then after training is done, it will upload the generated training model to Amazon model artifacts to Amazon S3, and the training job is completed. Okay, so there you can see it will create a new folder with our model name XGBoost model. So here you can see our this basically I run it 2 times, so that's why it's showing 2 times. So basically this is our model artifacts, and it shows this out model artifact, and it is in zip format tar.z gz, and it will basically generate these after this training occurs. It We can see like the output of that into by running this xg model dot model data. So it will show us the where is the output of that. You can see from like directly from notebook, because in real world we generally don't get the console access to see it here. So you can use this command to do that. And after that I am running this rule output variable path. So I will select where is my output reports output is remaining, because it basically generate these two report. First is the create a XGB report, and then this is profiler report. Okay, so you can see the first report it generated in the starting here. It says create XGB report, and the second report it generate is this profiler report. Okay, and we are going to only build for the what we are used for the training purposes 152 second. So after I saved that path, that is XGB output path, where that the S3 which we have created. So you remember this one which we created in the last one, and then we have the data. We have this data set, and the model is in this XGB model. Okay, so which is the latest job name we created after this. So this is the latest job which we created. So this is this one, and our both the reports is in the rule output. So that's why I go there. So you can see both the reports, create XGB report and the profiler report is there. I basically like put it into a variable and try to list it. Okay, I use this recursive flag to so that I can see inside elements of those as well. Okay, so there are two items in the XGB report item, and the profiler report have several items, and then I try to list it out here. Okay, and to if you want to download it here into our notebook, we have to just replace this list with the TP and press Shift Enter to execute this command. Okay, so it we got an error that it requires some path. So yeah, okay, because we have to copy, we have to provide where we want to copy. So I want to copy it in root. So now press Shift Enter. So you can see it started downloading it, and we have like got it here, and you can see these two folders has been created. I guess this is visible on the screen as well. Yes. Okay, please let me know if you like audio and video are going correct, if anybody is watching. Yes. So these two reports I have got in my SageMaker instance as well. So this is a simple command of AWS CLI through which we can download anything from our notebook from our Amazon S3 bucket. Okay. So I hope till here everything is clear, and we also can get that file link also of that training report. Okay, so for that we have to utilize the IPython display library. So we can do that. First we will import it, ipython.display. Yes, and then we will import file link, as well as we will be required because file links as well. Okay, then press shift enter to execute it, and then we are going to display. So we will get a file link of that. Okay, and we can simply write it as a string here. Click here to view XGB. What is the report? Create XGB report, right? Or basically I will in a human term I will write, because that create XGB report is known as create XGB training report. Okay, and then I will put the file link. It is create XG boost report, right? And let me check what is the name of. So this is the HTML that is we are want to display it, because HTML format is for that. So XG boost underscore report dot HTML. Okay, so press shift enter, and you can see there is a link which we got. So if you click it, you can see this is our data set, and you can see the confusion metrics of it, and all those loss versus step graph, and everything is there. You want to utilize all these feature importance, accuracy rate, and operating characteristic curve, distribution of residual at the last saved step. So this help us to get this report, and we can see how is our result of that classification report, what is the weighted recall F1 score of our confusion metrics. Okay, so this give us an in-depth of how is our training weight. And if you see it, it is quite well. As we can see, everything is about 0.8, so which is a very good uh, our model is perfectly fine and can predict the results very well. Okay, and same we are going to do it for the our profiler report as well. Okay, same you can do it for, and similarly way you have to display and just create a file link, and for that file will be profiler report.html. Similarly, if you go to here, there will be profiler report.html, so this will be required to be displayed. So basically if you want to just see where is your model state, so this is important for us. So our model training is fully completed, and we are going to, this is our model where it is stored, which you can see here as well, the output section, model.tar.z. Okay, So in the next video, we are going to deploy this model and then evaluate it, and then we will close this video. Thank you so much for watching this video, and see you guys in the next video. If you like this video, make sure to subscribe the channel, like the video, and share this video with other. Thank you.